All right, so how do we graph reciprocal functions? We've graphed sine, cosine, and tangent, but now it's time. We're going to look at secant and cosecant today. Okay, so the first thing that I need to remember is that cosecant x is just 1 over sine x. Okay, and that secant of x is 1 over cosine of x. So on these graphs down here, I'm going to make some quick sketches of sine x and cosine x. So go ahead and pause this, and you guys, sketch the parent functions for sine x and cosine x on two graphs. Okay, so now we have our two parent functions. So let's investigate these. Here, if cosecant is 1 over sine, well, if the sine value is 0, 1 over 0 is undefined. So here I actually have a vertical asymptote. Okay, and anywhere that the sine value is 0, you have a vertical asymptote. Okay, so if we continue graphing, at pi over 2, we see that the sine value is 1. So 1 over 1 is 1. And down here at 3 pi over 2, 1 over negative 1 is negative 1. And the way that these functions behave is that they actually just kind of approach their asymptotes like this. So again, anywhere that the sine function hit the x-axis, or the midline if we're going to be moving this around, anywhere that it hits the middle, we have these asymptotes, and at their max and mins, we get these parabolas that either open up or down. The cosine function works exactly the same way. Anywhere that it hits the axis, because 1 over cosine is secant, so 1 over 0 is undefined. And then we just go to their maxes and open them up. And these actually are going to continue over here. We just can't see that. And their mins would open down. Just so it's a little bit more clear, I'm actually going to make these a little bolder to show you what these functions actually look like. So there's cosecant, and here's secant. And then we would typically just represent the sine and cosine with dashed lines, just to know where we need it to be. So to graph, we have to graph the points of sine or cosine. Right? So here's what we did here with this dashed line. We draw a vertical asymptote where the graph hits the midline. So any of these points, we have vertical asymptotes. And at the maximums, we open up, and at the minimums, we open down. Alright, so let's jump right into it. Negative 2 secant times 3x minus 6 pi plus 1. I'm going to treat this like I'm graphing negative 2 cosine of the same thing. So the first step is going to be to factor out that b. Y equals negative 2 secant 3 times x minus 2 pi plus 1. Alright, so here the a is negative 2, which will give me an amplitude of 2. The b was 3. Alright, so the period is going to be just 2 pi over b, 2 pi over 3. I find my increment the same way. Just 2 pi over 3 times a fourth. So that's pi over 6. The h, we just remember to do the opposite. That's positive 2 pi with a k of 1. Now, since I'm graphing this like a cosine, remember that the starting point would be at h, and then the midline minus this 2, since this is a minus. So let's just get right into graphing this. I'm going to start by graphing my h of 2 pi. So here's my h of 2 pi. Now I have to add pi over 6 to that. So I need them to be in like terms. This is 12 pi over 6. So that takes me, let's see, 1, 2, 3, 4. 13 pi over 6. 14 pi over 6 is going to reduce to 7 pi over 3. 15 pi over 6. And then 16 pi over 6 reduces to 8 pi over 3. Okay, now get rid of these non-reduced terms. 2 pi is away from the y-axis, so we're over here. Here's my y-axis. The midline was shifted up to 1. So this is my midline. The amplitude is 2, so it's going to go up to 3 and down to -1. Now, I'm going to graph this just like I was graphing a cosine function because it's secant. Okay, so my starting point is at 2 pi -1. And I go to the midline, above the midline, back to the midline, and down. Alright, now I'm going to draw this with a dashed line because this isn't actually the function that I'm trying to find. Okay, now anywhere that we have where we hit the midline, that's going to be a vertical asymptote. So at these points where we hit the midline, we have vertical asymptotes. Then I just go to my max point and I open up towards the asymptotes, go to the minimums and open down. And there's my graph of the secant function. So again, if you can graph your sines and cosines, then you can graph secant and cosecant. Okay, one more example. We have y equals 4 cosecant pi over 2x plus 3 pi minus 2. Cosecant's related to sine, so this is y equals, factor out the b, 4 cosecant pi over 2 times x plus 3 pi divided by pi over 2 is the same thing as 3 pi times 2 over pi, so this is going to be 6 minus 2. Okay, now we label everything that we know. Our a is 4, so the amplitude's 4. B is pi over 2. The period is 2 pi divided by pi over 2, so divided by, or times 2 over pi. So the period is 4. Divided by 4, that gives me an increment of 1. The h is going to start way back at -6, and the midline will be at -2. Okay, so I've got my x-axis here. I'm going to start with my h of -6. I've got 4 increments. The increments are 1, so just -5, -4, -3, -2. And look, the distance from -6 to -2 is 4, which was my period. Okay, here's my y-axis. It's going to go down to -2. That's my new midline. And it's got an amplitude of 4, so that goes up to 2 and down to -6. Now I'm going to graph this just like a sine function. Okay, but I'm going to use a dashed line. So since it's a positive sine function, start here on the midline, go up to our highest point, back to the midline, down, back to the midline. Okay, so I have this hidden little sine function happening. Anywhere that it hits the midline, we have our vertical asymptotes. So we've got a vertical asymptote here at -6 and -4 and at -2. And just like all the others, wherever we have our maxes, we open up towards the asymptotes, and our mins we open down. And that's graphing secant and cosecant.